3 that we are going to do. So in medieval times, scholars used the term impetus as a way to describe why an object traveled a certain distance after being thrown. So this is a vector that could look something like this that has a magnitude. So the object traveled along a straight path until this impetus ran out or fell to the ground. Impetus no longer describes projectile motion, but is related to our definition of momentum. So whenever an object is moving, that's when we say that it has momentum. The simplest case to consider is the case when an object is moving in a straight line with constant velocity. So we define linear momentum as P with a vector on top, that's your momentum, times mass times your velocity. So P is the momentum, M is mass, and V is velocity. So this is a vector quantity. You must provide a direction. The unit of measure for momentum, since we have mass, that will be in kilograms. Then we multiply it by the velocity, and that's going to be meters per second. And that will be your unit for momentum. Let's do a simple example using P equals M times V. An object moves north with a constant velocity of 3 meters per second. If it has a weight of 8 kilograms, what is its momentum? So our equation to calculate momentum is P equals M times V. M was given to us in this question. It is 8 kilograms. And V is 3 meters per second. 8 times 3 is 24. And we're left with the units of kilograms times meters per second. Remember, this is a vector, so we do need to provide a direction. In the question, it says an object moves north, so our direction is just going to be north. So all the regular vector rules still apply to momentum. Two momenta can be added together along with their vectors. So we're going to use a vector addition. Here's an example of that. An object moves north at 3 meters per second. Another moves east at 4 meters per second. We want to find the total momentum if we know the mass is 10 kilograms. So I'm going to go ahead and draw our vector addition. This is 4 meters per second east. I'm going to add a vector that's 3 meters per second north. And I'm trying to find the resultant, which is going to look something like this. I'm just going to call that V, our resultant vector for velocity. And we would usually calculate this by using Pythagoras because we do have a right triangle. So if I want to calculate V, it's going to be the square root of 3 meters per second squared plus 4 meters per second squared. Which is also 9 plus 16. 9 plus 16 is 25. The square root of 25 is 5. And we were calculating velocity, so 5 meters per second. This is a vector, so we do need to find the direction. This is the angle we're looking for in here. So theta is tan inverse of opposite over adjacent. Our opposite is 3 meters per second over 4 meters per second, which is 36.9 degrees. Now we're going to find momentum, which is P is equal M times V. The mass was given to us in the original question. It's 10 kilograms. We just found that resultant velocity, which is 5 meters per second. So our final answer for momentum is 50 kilograms times meters per second. And remember, it's a vector, so we do need to add the direction. It's at 36.9 degrees. And because of how it's placed, we're going to have 36.9 degrees north of east. It's okay to represent your direction as east of north, but you do have to calculate the new angle, which would be 90 minus 36.9. Okay, I'm gonna move on and look at impulse. So in order to move an object that is at rest, you have to apply a force over a period of time. Even if the object is moving, a force will change the direction or magnitude of its motion. This force applied over some time is called delta t, and it's called an impulse. So your impulse formula is going to be I for impulse. It is a vector, and it's equal to force times change in time. Or you can state this as change in momentum. So as a note, remember that force is a vector. So impulse is a vector as well. Because an impulse will cause the magnitude and direction of the motion to change, it will also change that momentum of an object. Let's do an example of this. A golf ball is hit by a club. The contact between the two lasts for 0.5 milliseconds. The ball weighs 46 grams, and it moves with a velocity of 70 meters per second after the contact. What force is acted upon the ball? The first thing we need to find is our change in momentum. So we're going to calculate the change in momentum, which is mass times velocity. So our mass was 46 grams. We need to change this into kilograms. So you're going to divide this. And once you do, you're going to get 0.046 kilograms. Remember, you would divide that by 1,000. Okay, and then our velocity, it says it moves with a velocity of 70 meters per second after the contact. So this is your V final. So our V final then is 70 meters per second. Now we're going to look at V initial. Your mass doesn't change, is going to be the same. But your golf ball doesn't move from the beginning. So your initial velocity is going to be 0. Now we're going to do this calculation. 0 times 0.46, that's just 0, so that's gone. So we have 3.22 kilograms times meters per second. Next thing we're going to do is find our force, and we're going to use that new impulse equation. And we'll just rearrange this so that we're solving for force. So force is impulse over time. Impulse is the change in our momentum over our change in time. Our change in momentum was 3.22 kilograms times meters per second. Our change in time, we're given the time as 0.5 milliseconds. So we do need to find this in seconds. Be 0.5 times 10 to the power of negative 3 seconds. So we need to do the conversion from milliseconds to seconds. And I'm going to put that in the bottom of our fraction. And do our calculation. It's going to be 6.4 times 10 to the power of 3 newtons is our final answer. Let's do another example. A bullet with a mass of 25 grams strikes a block of wood at 300 meters per second and exits the other side at 100 meters per second. If the bullet is in the wood for 0.1 seconds, what force does the wood exert on the bullet? Okay, so we should probably organize our information first. We can do this on the side. Mass was given to us. We're going to do the conversion to kilograms, which is 0.025 kilograms. You would divide 25 by 1,000 to get that. Your initial velocity is 300, strikes a block of wood at 300 meters per second. And then exits the other side at 100 meters per second. So that is our V final. Our time duration is 0.1 seconds. Okay, so we know the equation for impulse. I is F times delta T, change in time. I'm going to change impulse as the change in momentum. And we're trying to solve for force. So I'm going to rearrange, divide both sides by delta T. And we're going to fill in our information. So the change in momentum is going to be m times v final minus m times v initial over time. So mass was 0.025 kilograms. V final was 100 minus 0.025. V initial was 300. All over 0.1 seconds. So we're going to go ahead and do that calculation using our calculator. Force is going to be 50 newtons, and it's going in the negative direction. Or you can say it's going to be 50 newtons opposing the direction of the bullet. Lastly, we're going to look at impulse as an area underneath the curve of force versus time. So please copy down the graph that I have right now. So if we're looking for the impulse, we can just find the impulse to find underneath this curve, which means we're going to break this graph up into easy pieces where we can find the area. So I'm going to break it up right here. So we have a right triangle as one of the areas we're going to calculate. And also over here, then we have a rectangle that we can calculate the area of, and also another triangle. And we're going to use the fact that area is base times height. Our base in this case is delta T. Our height in this case is our force, and this will give us the impulse. So we're going to find the three areas to find the impulse from 0 to 5 seconds given the graph. I'm going to call this section 1, this section 2, and this section 3. So impulse is F times delta T. This is going to be our first area plus our second area plus our third area. For our first area, we have a right triangle. This is going to be 2 times the height, which is 5, divided by 2 because this is a right triangle. Then the area of the second section is a rectangle, which is base times height. This is going to be 2 times the height of this rectangle, which is 5. Then lastly, our base for our number 3 is 1. We're going to multiply by its height, which is 5. Then divide it by 2 because it's a right triangle. Now we're going to simplify. We have an area of 5 for the first triangle, an area of 10 for the rectangle, then an area of 2.5 for our last triangle. Adding these all up, we get 17.5. Now for our units, we are multiplying force, which is in newtons, and time, which is in seconds. So our final unit is going to be Newton times second.